How do farmers breed millions of giant groupers every year without wiping out the ocean? These massive fish can grow over 300 kilograms, yet hatcheries now produce millions annually using high-tech breeding, precise hormone triggers, and cutting-edge water systems. Why does it matter? Because wild groupers are vanishing, but smart aquaculture is filling the gap, boosting economies, feeding demand, and saving reefs all at once. With the industry growing at 6% a year, this is seafood's silent revolution. How will this impact your plate, your planet, and your future? Stay with us as we break it all down. And don't forget to subscribe for more real-world insights. Giant grouper farming has gained importance due to several key factors. These fish can weigh over 300 kilograms, 660 pounds, and command high prices in Asian markets, especially in China, making them economically valuable. With wild populations declining from overfishing, aquaculture offers a sustainable solution by easing pressure on natural reefs. Nutritionally, giant groupers are rich in protein and omega-3 fatty acids, providing a healthy food option. Beyond nutrition and market demand, farming giant groupers boosts local economies by creating jobs and encouraging aquaculture growth. According to the Food and Agriculture Organization, global grouper aquaculture production has increased steadily by about 5 to 7% annually over the past decade, highlighting the sector's rapid expansion and importance in meeting global seafood demand responsibly. This combination of economic, environmental, and health benefits makes giant grouper farming a vital part of modern aquaculture. The breeding process begins with selecting mature, healthy giant groupers as broodstock. These are the parent fish responsible for producing strong offspring. Farmers prioritize disease-free individuals with superior genetic traits to improve survival and growth rates in the next generation. Typically, broodstock weigh between 30 to 150 kilograms and are 4 to 7 years old, which means they've reached sexual maturity and are ready to spawn. These fish are kept in spacious, clean tanks, or sea cages, where they're fed nutrient-rich diets high in protein and essential vitamins to boost fertility and egg quality. According to the World Aquaculture Society, proper broodstock nutrition plays a critical role in improving egg viability and larval survival. This careful selection and management process lays the groundwork for large-scale, high-quality grouper production. In captivity, giant groupers rarely spawn on their own, so farmers use scientific methods to encourage reproduction. One of the most effective techniques is hormonal induction, where broodstock are injected with hormones like human chorionic gonadotropin or gonadotropin-releasing hormone analogs to stimulate egg and sperm release. Alongside hormones, farmers manage environmental factors such as water temperature, light cycles, photoperiod, and water quality to mimic the fish's natural breeding conditions. Spawning usually takes place late at night or early morning, so farms must be ready to collect the fertilized eggs immediately. According to aquaculture reports, these hormonal and environmental strategies boost spawning success rates from below 10% in natural settings to over 80% in controlled systems, making induced spawning a key practice in large-scale grouper farming. After successful spawning, farmers move quickly to collect fertilized eggs using fine mesh nets or specialized egg collectors placed within tanks or sea cages. The eggs are then carefully transferred to incubation tanks, where conditions are precisely managed. Water temperature is maintained at 28 to 30 degrees Celsius, with optimal oxygen levels and salinity to support healthy development. Within 24 to 36 hours, the eggs hatch into tiny, delicate larvae. This stage is extremely sensitive and requires constant observation to avoid losses. According to the Food and Agriculture Organization, survival rates during incubation can reach up to 90% under ideal conditions. Though achieving such high success demands vigilant care and environmental stability, this process ensures a healthy next generation, laying a strong foundation for large-scale giant grouper farming. The larval stage is the most delicate part of giant grouper farming, requiring precise care to ensure survival. Newly hatched larvae are fed live food like rotifers and Artemia naupli, enriched with essential fatty acids to support development. These larvae need feeding as often as every 2 hours to maintain growth. Maintaining high water quality is equally important. Low ammonia and nitrate levels, along with continuous aeration and filtration, are crucial to prevent stress and disease. Hatcheries use dim lighting and specially designed tanks to reduce larval stress and enhance survival. A 2022 study in the Journal of Fish Biology found that advanced feeding practices have increased larval survival rates from under 5% in the 1990s to over 25% in today's hatcheries, marking a major leap in larval management success. Enjoying this? Subscribe and hit the bell to stay informed. Around 20 to 30 days after hatching, giant grouper larvae transform into juvenile fish known as fingerlings. At this stage, farmers begin weaning them off live feed, introducing formulated pellets rich in protein, vitamins, and minerals to meet their nutritional needs. The fingerlings are transferred to larger tanks or sea cages with reduced stocking density, allowing for better movement and healthy development. Consistent monitoring, including size checks and health assessments, helps detect and prevent potential diseases early. By maintaining proper conditions, fingerlings can reach an average weight of about 500 grams within 6 months. At this point, they are robust enough to move into grow-out systems like larger sea cages or ponds, where they continue maturing until market size. This stage is critical for building a strong, disease-resistant stock. Today's giant grouper farms rely heavily on advanced technologies to boost efficiency and sustainability. Automated feeding systems deliver accurate portions, minimizing feed waste and supporting consistent growth. Water quality sensors provide real-time data on oxygen, pH, temperature, and ammonia, allowing farmers to maintain stable and healthy conditions. Through genetic selection programs, farms use DNA analysis to identify broodstock with faster growth rates and stronger disease resistance. In addition, strict biosecurity protocols, including quarantine tanks and daily disinfection routines, help stop the spread of infections. According to a 2023 report by the Global Aquaculture Alliance, farms adopting these technologies can now produce up to 5 million fingerlings annually from a single facility. These innovations are redefining what's possible in large-scale grouper aquaculture while protecting both fish health and the environment. Raising millions of giant groupers comes with real challenges, but smart strategies help farmers stay ahead. Disease outbreaks, especially from Vibrio bacteria and parasites, pose major risks. Farmers tackle these using probiotics, targeted vaccines, and carefully managed antibiotics. To reduce environmental impact, many adopt integrated multi-trophic aquaculture, where seaweed or shellfish are farmed alongside groupers to naturally absorb excess nutrients. High operational costs, including feed, labor, and energy, remain a hurdle, but are managed through automated systems and efficient planning. According to research published by Aquaculture International, these innovations help lower long-term costs while boosting sustainability. Despite obstacles, continuous advances in aquaculture science and farm management are making giant grouper production more resilient, responsible, and profitable on a global scale. Giant grouper farming plays a major role in supporting coastal economies across China, Indonesia, Malaysia, and other parts of Southeast Asia, providing thousands of jobs in hatcheries, grow-out farms, and supply chains. It also serves as a sustainable seafood alternative, easing pressure on wild grouper populations and helping protect vulnerable coral reef ecosystems. The global grouper trade is booming, with the market valued at hundreds of millions of dollars annually, driven by demand from premium seafood buyers. According to the FAO, grouper aquaculture is growing at an average rate of 6% per year, fueled by rising consumption and eco-conscious practices. This growth is not only transforming seafood markets, but also proving that responsible aquaculture can balance both profit and planet. In the end, giant grouper farming isn't just about fish, it's about saving oceans, feeding millions, and supporting communities. How will this growing industry shape the future of seafood on your plate? Can smart farming truly protect our reefs and wild fish for generations to come? Drop your thoughts in the comments below. We want to hear from you. And don't forget to like, subscribe, and hit the bell so you never miss these eye-opening stories.